My name is Xiantong Wang, and I'm from China. Right now I'm a third-year PhD student. Previously, I was working on simulation work, MHD models, particle in-cell models, and the general space weather problems. That's the part I'm interested in. And since the machine learning is kind of prospering and become more and more popular, and we have enormous data available in space weather. So combining these two things together, utilizing the machine learning methods into the space weather problems is become more and more promising, and become more and more interested in that. So my role in the Solstice team is I'm building the data pipeline and testing the machine learning model and analyzing the solar images using the machine learning. So that's my role in the Solstice group. It started when I was in undergrad. So when I was in undergrad, I just entered the university. I knew that there's a plan about solar probe. It's a satellite that launched recently, but it wasn't launched like 4 years ago. But I think it's really fascinating because people sending a satellite, human-made things, that's so close to the sun, which, well, the sun, is very hot and the temperature is really high. But I think it's really fascinating. And since the sun is kind of like a source of the energy of our solar system, and it's really important to us, to our Earth's environment. So I think that makes me interested in this field, because I want to explore more about how the sun interacts with our Earth and how it may have impact on our daily lives. And that's the reason why I'm interested in this field. And that's specifically why I'm interested in the physical modeling, because you want to know about something that could be, not that good before it really happened. So physical modeling can help us to at least know about what will happen in the future. I don't want to describe a lot about the stay-at-home time because stay-at-home time, everything is messed up. But if it's not in this special time, I will get up at maybe 9 o'clock or 8:30 in the morning, and I will walk to my office and check my, it's just daily life, check my emails and started coding, debugging, and then I will go out for lunch. I usually eat outside, and in the afternoon, well, basically it's a replicated time. It's about the same what I did in the morning. And I usually it depends. Sometimes I feel I'm really tired. I will go home earlier, and maybe sometimes I feel okay. I like to work longer. I will go home later, because research work the flexibility is what I'm really enjoyed. And for my personal life, I'm a huge fan of classical music. I usually practice violin after work, and I also play the violin in our university's student orchestra. And that takes most part of my actually free time. And I enjoy listening to the classical music. I enjoy play the violin as an instrument. And then at night, usually I will, because doing simulation, sometimes your job will finish at night. Maybe I will quickly look at it, and then I will go to bed. I don't have much. My life is not that diverse, I would like to say, because I think I'm really interested in one thing, and I'm trying to explore deeper and deeper. So that's usually one of my day. And sometimes I will go out running for a while. Sometimes I will well, everyone do that, grocery shopping, and I like to go to the park and run for an hour or maybe longer. So that's usually what my life looks like. So recently, I just published a paper about, actually it's related to Solstice. So I utilize the machine learning method to do a solar flare prediction. And we have currently the best result what we have in the field. And I also find a new thing that using the data we got from different solar period actually affects our final prediction performance. So that this is kind of like an intuition to the people that when we want to train and test our model, we must consider the solar cycle into our work. Otherwise, we may have a result that really have a large bias in it, and that will be misleading to the field. So I think that's really interesting. And currently, I'm working more to explore the reason what's causing this and what could be improved. I just stepped in for a couple of years, and I'm really I don't know if I have started my career, so I don't have much advice to the researchers, but I do have some feelings that I think it's about the general research work is you may fail all the time, and you need to live with the failure and find something that may lead to a potential success, and you have to get used to it. That's basically what I have right now, because I'm since I just started doing research work was like 2 or 3 years. I think it's fine that I feel I have a lot of failure things all the time, but I'm very happy with it because at least it exempts something that you cannot do in the future. So I think Solstice will be very important. I think my goal is to really build using, with the help of this project, we will finally build I think an entire system that is really can help us to do the data pre-processing, do the prediction, and combine all the different parts of our solar and Earth system, combine them together and give us the state-of-the-art prediction results of how the solar activities will impact our Earth. And this system should be, I mean, it can be used in real time, and it can run like 24/7, and it can give us very reliable results and give us the best. People can using the information the Solstice outputs as a advice of how we dealing with our satellite, how we dealing with our missions, and this should be really using the front technologies and combining the large scale computation and also the GPU computing. So I think we need to use the newest technology and provided a real sophisticated system that can deal with every factors, almost all the factors in the solar Earth system.